Hey guys, this is our last video on functions. This one's on algebra and composition with functions. And so this time, rather than evaluating quite so much, we're going to actually just work with the functions themselves. So a little bit more algebraic, a little bit less computational. This first one goes g minus f of x, and so it can be written this way. You can also write it g of x minus f of x. You'll see both those notations, and sometimes they'll just do the g minus f. They all mean the same exact deal. So we're just going to take g right here and then subtract f from it. So I'll go minus with the parenthesis, f is right here, 4x minus 1. Again, very important to get that parenthesis because otherwise the sign doesn't get switched on the terms after the first one. So that'll make a 3x plus 2, and then a minus 4x and a plus 1. And we can collect some like terms and get negative x and plus 3. So this one, f times g, and again we could have it f of x times g of x, or just the f times g like that, same stuff. And so this is just a FOIL, so f is 4x minus 1, g is 3x plus 2. And so this isn't, let me just say here, a lot of times students will think that that means multiply by an x. And remember, it's not. It's saying that f and g are functions of x. So it's just like having f of x times g of x. There's no multiplication of x. It's just that this is a function of that variable. So careful to not kind of take that as some sort of multiply. So there is a multiply though, and it's just the FOIL part. So 4x times 3x is going to be 12x squared. On the outside, I'm going to get an 8x. On the inside, a minus 3x. And off the end there, a negative 2. And then I can put together these couple of like terms and get 12x squared plus 5x and minus 2. Okay, so this next one, h minus f times g. And again, of x is just the variable. So you can think of it as that doesn't even need to be there. It could just be saying just like this. So f times g, and it will do this on the homework too. Remember, that's the one that we just did right here. So I'm just going to use my work, and it's the same prompts, and this is how the homework will go. So I'll just use my work from this problem for this problem. So h, let me get that copied down. So this is going to be 12x squared plus 5x minus 2, and then minus f times g. And so we have that right back here, and I think it's going to be the exact same thing. And I think on the homework it does similar stuff. Might be 2 times the value or something, but there's kind of a pattern to it frequently. And so here, since it's this minus itself, right, it's just going to distribute that sign, and then everything's going to cancel. Because now I'm basically saying something minus itself, so it's going to be a 0. But just to show it, there's our 12x squareds, our minus 5x plus 5x minus 2 plus 2. And so when it all cancels, nothing's left, so make sure you get a 0 down for that. This next one, h divided by f. And so if you are in 98, you haven't seen this reducing yet. It's going to show up in actually our next chapter. So I need to show you a little bit of a factor cancel situation here. And it's the same, it's basically the same idea as if you had, say you had 12 over 9. If you had something like that, you could factor, and then you can reduce the fraction and cancel. And so that's what we're going to do with this. I just did one here where I showed what these multiply to, and so you can see that when I factor, it's going to be this. I'm going to do the factoring anyways, just because I want to remind you how to do the factor, the magic method from earlier. So for that, we did 12 times negative 2, and that's going to be negative 24. And then what multiplies to be negative 24 and adds to be 5 would be positive 8 and negative 3. And so then I can say 12x plus 8 and 12x minus 3. And here I can reduce 4, here I can reduce 3. So h factored will be 4x plus 2 over 4x minus 1. What went wrong there? 3. Oops, that's a 3. Sorry about that. So 4 into 12 3 times, and then the 4x minus 1. And then that's over f, which is right here, it's the 4x minus 1. And so, and this is the only part that you haven't seen if you're 98. If you're 95, we just did this chapter, so it's familiar. But when I have the same factor top and bottom, I can just think of that as canceling as this like times a 1. And so then that's just going to leave the 3x plus 2 for the answer. Okay, so this next 5 through 9 I would have you guys try in class. So we're going to have h minus f. So h is right here, it's this thing. And then minus f would be this thing. And so I'll just go ahead and distribute that sign. And you could do it in your head too if you prefer, but I'll just kind of show the steps. And I'll make that a -3, careful to get that one. And then combining, I have 4x squared. 11 minus 4 would be 7x. And then 6 minus 3 would leave me 3. The next one is g times g. And so it's just this squared. So you could write it as x plus 2, x plus 2, or you could think of it as x plus 2 quantity squared. Either way, if you think of it as FOIL or this, you're going to get x squared and then plus 2x on the outside and another 2x on the inside. And that's that 2ab from the formula, and plus 4. So x squared plus 4x plus 4. If you thought of it this way, remember you just go x times x for x squared, and then 2 times x times the 2 in the formula for 4x, 2 times 2 for 4. So a little bit quicker when you learn that version, so I do encourage that. Okay, so this one is h over f, and so we'll factor this, and we kind of count on one of these things is going to cancel, but we'll go ahead and do out the steps. So 4 times 6 would be 24, and I need two numbers to multiply to 24, add to be 11, so it sounds like 3 times 8. And so that'll be 4x plus 3, and then 4x plus 8. And I can reduce out of 4 right here, and that gets rid of that fake 4. So I have 4x plus 3, and that's going to be x plus 2. And so then that's supposed to be over f, which is the 4x plus 3 part. And then that allows me to cancel those, and then what's left is the x plus 2. This one, it's just like the GG, but this time it's written f squared. So I guess since it's written that way, and again, not times x, it just means this thing times itself. So since they're using the squared notation, I'll go ahead and do it the shortcut way. Definitely a good trick to learn. So this will go 4x times 4x, 16x squared. And then we go, remember it goes a squared plus 2ab plus b squared. So the 4x is the a squared. 2ab, we just multiply these two together and double it. So that'll be 4 times 3 is 12, doubled is 24 with the x. And then the thing on the end, 3 times 3, b squared, makes 9. Let's see, so this one, I think we could, I can think of 2 ways to get that. That's kind of cool. So I could FOIL this out, and I would get f squared minus g squared, which I think I have both of those, and then I could just subtract. Or I could put f and g in here and then do the algebra and FOIL. I think I'll show it that way, but I hadn't thought about the fact that you could also make it f squared minus g squared, and then just plug those in and then expand it that way too. I think probably most people would see doing it this way, so that's what I'll show for the example. But 4x plus 3 is my f, and then on this one I'm subtracting g, so I would need to get a parenthesis around it, and x plus 2. And then f, this will be 4x plus 3, and then plus g, so plus x plus 2. So there's f minus g, and then f plus g. Here I didn't bother with the parenthesis because the plus is just going to collect as it is. So this one I'll distribute that through though, and get 4x plus 3 minus x minus 2. While I'm over here, I'll collect some terms. So that's going to be a 5x, and 3 and 2 for 5 right there. And then I can finish putting this side together. 4x minus x would be 3x. And then 3 minus 2 will give me a plus 1 right there. And then times this. And so then once I have that, then I can FOIL. So 3x times 5x is going to give me 15x squared. 3x times 5, 15x. 1 times 5, so that's a plus 5x. And 1 times 5 for plus 5. And I have some like terms there, so that'll be 15x squared plus 20x and then plus 5. Yeah, it makes me kind of actually appreciate this one a little bit. If you're good at those squares, let me just, I think I'm going to show it over here because I kind of like that. So it'd be 4x plus 3 squared and then minus x plus 2 squared. And we'll have to keep this, we're going to kind of think of it almost as brackets, so we're going to square this and then run the sign. So for this piece, I think I'll sneak down a little bit so I have a little more room. 4x times 4x will be 16x squared. 4 times 3 is 12, double it and get 24. So plus 24x, and 3 times 3 is 9, so that's when we just did over there. And that'll be minus x times x squared, 2 times x times 2, so these two together and then doubled, so that's plus 4x, and 2 times 2 makes 4. And then distributing that sign, I get 6x squared plus 24x plus 9 minus x squared minus 4x minus 4. And I have a few like terms, 15x squared, 24 minus 4 would be plus 20x, and then 9 minus 4 would be plus 5. So I think it's a little bit shorter. Yeah, I kind of like that version. So these ones are back to me doing them in class. So this one's a composite from the last section, just to kind of get things rolling with the composites in this section. So remember, for these we did the inside functions, we did f of negative 5. And so we just put a negative 5 right in here. And then f of negative 5 equals negative 6. And then once we have that, we can take that and put it back in here. Because f of 5, negative 5 really is negative 6. So it can go right there. And that tells me I'm going to find g of negative 6. So evaluating for g of negative 6, right here, so 3 times negative 6 plus 2, that's going to be a negative 18 plus 2, or negative 16. And so that's kind of what we saw back in the last section. This section we're going to do composites with the functions themselves. And I mentioned in the last section that we have 2 different notations. And so here's one of them. So this just says h of f of x. I actually prefer, and on the test I will use, I almost always use, I think, I pretty much always use this version, h of f of x. This feels to me a little bit more like what we're actually going to do. So in this case, the same way here that I found f of negative 5 and it made 6, which means really I'm going to evaluate g at this result at 6. We're doing that same thing here. We're saying we're going to evaluate h at f of x. We're going to actually plug f of x into h. I always kind of think of it as, okay, h is going to eat f. And so if I look at h up here, anywhere there's an x, f of x is going to go. So this is going to be in those. So the same way if this said h of, 7, say, I would put a 7 here and a 7 here. So now it doesn't say h of 7, it says h of f of x. H of f of x, well, what's f of x? F of x is this x minus 1. And so that means I'm going to evaluate h at x minus 1, which is f of x. So let me show you what that'll look like. So h of x minus 1, so you'll have x minus 1 squared, and then plus 4, x minus 1 again, minus 2. So this will be x squared. We're going to go 2 times x times 1, negative this time because of the sign, so negative 2x plus 1. I'll distribute that 4 through and get 4x minus 4 minus 2. And then after that, I just have to kind of collect up my signs, so or my terms. So minus 2 plus 4, so it's going to be plus 2x. And then I have a plus 1, and then minus 6, that'll be a minus 5. Okay, so this one's pretty similar, h of g of x. And so now I'm just going to do h is going to eat g this time. So that will look like this is going to go here and here. So 3x plus 2 squared, and that again is where it's nice to just be able to kind of bust that out. Plus 4, and then 3x plus 2 and minus 2. So expanding this, I'll get 3x times 3x is 9x squared. And then we do our 3 times 2 and double it. You can always kind of look at the 2 as a reminder to double it. It's not quite what it's doing, but right idea. So 6, 12 right there. And then 2 times 2 would make a 4. Now I'll distribute this one and get 12x plus 8, and then the minus 2 on the end. And then I just have to collect terms. So 9x squared up front, 12x and 12x should be 24x. And then I have plus 4 plus 8, so that'd be 12, but the minus 2 will be a plus 10. Okay, and these last 4 are the ones that have you try in class. So again, just kind of remembering the evaluate from the last section. We'll do f of 4, and so that'll be 4 times 4 plus 3, or f of 4 equals 16 and 3 is 19. But we don't want to stop at f of 4 because we're really trying to find g of f of 4. And so since f of 4 is 19, that means I'm going to find g of 19. So g of 19, I can just throw 19 right there. So 19 plus 2, and it looks like that's going to be 21. The next one, f of g of x, so that means f is going to eat g of x. So wherever there's an x in f right here, this is going to go in for that x, and that will be f evaluated at g of x. If it helps, you could also write it f evaluated at, so g of x is x plus 2. So if that kind of helps you see how you're going to plug that in, that's a totally good way to write it. So this is going to be 4x plus 2 plus 3, and then just distributing a little bit, 4x plus 8 plus 3, or finally 4x plus 11. Okay, and we got these last two. So h of g of x. So h is going to eat g of x, so that's this x plus 2. So that's going to go in for those x's. So that will look like 3 and then x plus 2 squared minus 5, x plus 2 plus 6. So that'll be 3x squared, 2 times x times 2, so 4x. 2 times 2 will make 4, minus 5x, oops, parenthesis right there, and then minus 10 and plus 6. And I'll run my 3 through, so that's going to be 3x squared plus 12x, and then plus 12, minus 5x minus 10 minus 6. I guess I could throw those together and make a 4 right there since I'm there, and I'll combine with this other 12 in a sec. 3x squared, I got 12x minus 5x, that's going to be 7x. And then 12 minus 4 will leave us a plus 8. And then this last one, so we're going to go, in this case, h is going to eat f. So everywhere there's an x in h, it's going to get that thing right there. So it's a lot like this problem, just a little bit slightly bigger numbers. So this is going to be 3 and then 4x plus 2, and oops, that's a 3 squared, and then minus 5, 4x plus 3, and then plus 6. It's just not getting better, is it? So here I'll leave this 3 out front. Expanding this, I'm going to get 16x squared. 4 times 3 would be 12, doubled would make 24x, and 3 times 3 will be 9. And then distributing, I'll have minus 20x and minus 15 plus 6. And I can run that 3 through and get 48x squared. 3 times 24 would be 72x plus 9, and then minus 20x. Down 15, up 6, that'd be minus 9, which then I think goes with that one. Oops, wait a second, I have a bad sign. Minus 9. Oh, I think I'm good. And so then that's going to be 48x squared plus 72 minus 20, so that'd be 52x. I just found my error. Okay, it's right here. Yeah, I love when I catch this before I shut the video off. So let me fix that real quick. So 3 times 9 is 27 right there. And so then 27 minus 9 is going to give us a plus 18 right there. Sorry about that.